friend, welcome to your channel, that is Civil Engineering Choice. And we know that already we have started the series of calculation of shear force and bending moment diagram, and already we have covered few basic cases, that is simply supported beam carrying a different point load. Okay, already we have discussed all these things. Now today we are going to discuss about the numericals, and then we will compare when the both moments, means when any simply supported beam carrying a centrally movement, whether it is clockwise or anti-clockwise, how will be that movement will affect on the shear force and bending moment diagram. So first हम consider करेंगे, let's say simply supported beam having span 10 meter. Okay, total span we are considering over here 10 meter, and that movement, clockwise movement is of 50 kilonewton meter, which is acting at center. Okay, so means distance from A point is 5 meter and distance from B point is 5 meter. Okay, so we are considering this is at center. Now as we know that first we have to calculate the support reaction. Support reaction we can calculate by using the equilibrium condition, and we know that the first equilibrium condition we are using summation ma is equals to 0, and another equilibrium condition there we using summation fy equals to 0. So first take the summation ma equals to 0, and for the support reaction calculation we can use any sign convention. So here we are going to use the clockwise movement as a positive. Okay, and we are taking movement at A point. Okay, so the moment of RA, let's say at A point is RA reaction, at B point it RB reaction. So moment of RA is 0. Okay, so RA into perpendicular distance is 0, and the moment of this, it is clockwise, so it will be the clockwise, means positive 50, and the moment of RB is anti-clockwise, so the moment of RB at A point is RB into perpendicular distance. Now perpendicular distance is how much? Okay, 10, so RB into 10. So what will be the equation for the summation MA? So for summation MA is equals to 50 minus RB into 10, and when we solve this equation we will get RB is equals to 5 kilonewton. Now here we got the first support reaction at B point, that is RB is equals to 0. Now similarly we can apply the another equilibrium condition, that is summation Fy is equals to 0, means sum of all vertical forces is equals to 0. Now here we have considered RA upward, and this support reaction is also upward. So both RA plus RB, why plus? Because both forces or the both support reactions are going upward, so we are not taking this 50 kilonewton meter in the summation Fy, because it is a movement and we are applying the summation Fy. Summation Fy means what? Algebraic sum of all vertical forces, not a movement. So that's why we are not taking this movement in the calculation of summation Fy. So RA plus RB equals to 0, but RB already we have calculated, where RB is what? 5. Okay, so RA will be minus 5 kilonewton. Okay, so now here we got both reaction. Okay, support reaction, we can say support reaction at A point is minus 5 kilonewton and support reaction at B point is plus 5 kilonewton. So once you calculate the support reaction, the next step is what? To find shear forces at each point, and we know that to find the shear forces at each point we are considering the section on left and right part of that particular point. So here we have to take the section at left part of A, then and after that right on the A, and then we are focusing on the left part of that particular section, because we have started our calculation from left to right. Okay, so another most important thing is what? If you remember in the last video or in the standard case, we have not to calculate shear force at C point. Okay, the most important thing is what? When your force is there, whether it is point load or the UDL, when that force is there, only we need to take the shear forces at this point. Okay, if any point is subjected to a couple or the moment, no need to take the shear forces at this point, because that moment will not comes under the shear force. Okay, so here we are going to consider shear force only at A point and directly at B point. So again, as we discussed, we have to take the section. Okay, so in the shear force calculation, first, yeah, this is most important thing. In the shear force calculations we have to go with the proper sign conventions with the sagging and hogging. already we have discussed it in the previous some videos, so you can refer that video. I will give the link of that videos in the description box, so please go through that videos, so you will get idea about that sign conventions. Okay, so as per the discussion, if any section having the upward force on the left side, so that force should be positive, and here we have started our calculation from the left to right, so we are focusing on this force only. Okay, left of the force. Okay, it means if any force is upward on the left of particular section, so that should be positive, and if downward on the left of that particular section, so it is negative. Okay, so now here the first, when we are taking the section section at a left. Okay, so a left, we are taking section at a left, and then we need to focus on the left. There is no any force, that's why a left is equals to 0. Now after that, take the section on a right. Okay, so see, if we take the section at a right, so on on left of that particular section, one force is there, that is Ra. Okay, and the direction of that Ra is upward, so we need to take that Ra as a positive, but the magnitude of that Ra is minus 5 kilonewton, so we have to take it minus 5 kilonewton. It means the shear force at a right is minus 5 kilonewton. So now it is minus. So in the shear force diagram, if you consider this is the baseline, okay, so our shear force diagram will go down. See here, okay, shear force diagram will go down, and it is negative shear force diagram. Now a left, a right has been finished. Now next point directly we can consider as a B. Again take a section on left of that B point, and the focus on left of that particular section. So only again one force is, that is Ra. Okay, only one force is there, that is Ra. So again B left, Ra is equals to minus 5 kilonewton. So that shear force is constant from A right to B left. Okay, it is constant. Okay, now again we have to take the section on right of that particular point, B point, and the focus on left. Now here we can see two forces are there, that is Ra and Rb. Okay, two forces are there. Now Ra is upward and Rb is also upward. Okay, both forces are upward, so the reaction will be, okay, reaction will be Ra plus Rb, means shear force B right is Ra plus Rb, but Ra is what, minus 5 kilonewton, and Rb is what, plus 5 kilonewton. So minus 5 plus 5, it will be 0, means in the shear force diagram, our diagram at B point will close, means it comes to the base point or the base line. Okay, now this is shear force diagram. Now next is what, calculation of bending moment diagram. Okay, and for the calculation of bending moment diagram, here we have to calculate the bending moment at each point. Okay, like A point, C point, and B point. But if you see at B point, there is a moment. Okay, the moment is there. So when any point is subjected to a moment, we need to take the moment at left of that particular point and right of that particular point. Okay, already we have discussed it in the previous video. And sign convention is also important. Now here we are considering sign convention, means if any clockwise movement on the left of that particular section, so we need to we are considering that movement as a positive, and anti-clockwise movement as a negative. Okay, again I am repeating it, we have already discussed that sign convention and the theoretical part in the our basic video, so you can refer that video. Okay, now the bending moment at A point. Now here we are taking section at A point, and we are focusing on the left of that A point. Again no force, so bending moment is 0. Okay, but now the next point is what, C left. Okay, means we have to take the section at C left and then focus on the left part of that section. Okay, now the moment is what, okay, now one force is there, that is Ra. The moment of that Ra is Ra into perpendicular distance. Okay, moment will be Ra into perpendicular distance, and the perpendicular distance is 5. Okay, perpendicular distance is 5. See, we are taking section at C left, it means exactly we are taking the section at C point. Okay, not at a far distance. Okay, means that section having not a far distance from the C point, it is closely C point. Okay, but we are focusing on the left of that C point. Okay, so now Ra is what, Ra is minus 5, so minus 5 into 5, it is 25. So the movement of C left okay, moment of C left is minus 25 kilonewton meter. It means our bending moment diagram will go down. Okay, we'll see it. Okay, bending moment diagram will go down. Now after that we have to take the section on left of C point, sorry, right of C point. Okay, right of C point, and then focus on left part. Now here we can see one force and one moment is there. Okay, one force and one moment is there. The force is Ra, so Ra into perpendicular distance is 5. Okay, and due to the clockwise, as per the sign conventions, we need to take it positive. So Ra into 5, then again moment of this plus 50. Okay, the moment, okay, plus 50. So Ra is minus 5 into 5 plus 50. So answer will be plus 25. Okay, answer will be plus 25, means the bending moment on B right is plus 25. See, Ra into L plus M, that is minus 5, 10 by 2 plus 50, that is minus 25 plus 50, it is 25. So our bending moment diagram is suddenly rise in the B up. Okay, now again take moment at B point. Okay, again take section at B point and then focus on left, and if you see there, okay, so again two forces are there, that is Ra, one force, and moment. Okay, Ra and moment. So now here Ra into perpendicular distance, in this case now Ra into perpendicular distance is 10 because we are taking moment at B point. Okay, and Ra distance from B point is 5 plus 5, 10. Okay, and plus 50. Okay, plus 50. Moment is what? Force into perpendicular distance, not moment into perpendicular distance. So if any moment is there, we need to take that moment as it is in the moment calculation. Okay, so now Ra is what? Minus 5, okay, into 10 plus 50. So minus 5 into 10 means 5 into 10 is minus 50 plus 50. So it will be 0. Okay, so moment at B point will be 0. It means it will close up to the B point. So this is the shear force and bending moment diagram for the first case. Okay, now we'll see the second case. Now so this is our second case. तो वीडियो बड़ा होगा इसलिए मैं पूरा एक्सप्लेन नहीं करूंगा. So I will just explain main thing. Okay, so support reaction, just apply summation Ma equals to 0, again Ma. Now see, here again we are considering clockwise movement as a positive. Okay, clockwise movement as a positive. Now here the movement is anti-clockwise, so minus 50. Okay, it is minus 50 into, okay, into Rb. Rb, that movement is also anti-clockwise, so it is also negative. So minus Rb into 10. Okay, we are taking movement at A point. So minus 50 minus Rb into 10, where Rb is equals to what? Minus 5 kilonewton. Now here we have calculated the reaction at B point. So support reaction at B point is minus 5 kilonewton. Again apply summation Fi equals to 0, so Ra plus Rb, okay, where Rb is minus 5, so Ra will be the 5 kilonewton. Okay, now these are the support reaction. At A point, Ra is equals to plus 5 kilonewton and Rb is minus 5 kilonewton. Now the next, calculate the shear forces. Again for the calculation of shear force, take a section on A left, then A right. So if you take the section at A left, okay, so at A left there is no any force, so A left is 0. But A, if you take the section on A right, okay, so on A right there will be one force, 5 kilonewton. Direction of that force is upward, so take it positive. So shear force A right is plus 5 kilonewton. So plus means it will goes above the baseline. This is our baseline, so it will goes above the baseline. See, it is going above the baseline, and now in this case our shear force diagram is positive. Okay, now after that directly we can take the B point, because at C point there is a one couple or moment, so no need to take the shear force at C point. So directly we can go with the B left. So B left is again one force. If you take the section on B left, again one force is there, that is Ra. Okay, so Ra is upward, so it is positive. Okay, means from A right to B left our shear force diagram will be constant. Okay, see, our shear force diagram will be constant. Now B right, okay, now take the section B right, and if you see on the B right, okay, on the B right Ra is upward and Rb is upward, so both are positive, so Ra plus Rb, but Ra is plus 5 kilonewton and Rb is minus 5 kilonewton. If you put both values, plus 5 minus 5, that will be 0, means shear force diagram will close at this location. See, it will close at this location. Now after that, bending moment calculation, again same thing, take a section at particular point, okay, but at C point there will be couple, so we need to take the section at left and right at the C point. So bending moment at A point is 0. Yes, these sign conventions are important. Bending moment at A point is 0. Now bending moment at C left, okay, C left is what? RA into perpendicular distance 5, okay, RA into perpendicular distance 5, so it is 5 into 5, 25, okay. So now see, bending moment is positive, so it goes upward. Bending moment at this point is upward. Now when we take this section at C right, so at C right, again one force and one moment is there, okay. So moment of that RA is what? RA into perpendicular distance, so RA means 5 into 5, and the moment at C point is anti-clockwise, so it should be negative. So 5 into 10 by 2 means total span divided by 2, or we can say the 5 minus 50, so 25 minus 50, so answer will be 25, minus 25 kilonewton. Kilonewton meter means bending moment on C right is minus 25 kilonewton meter. It means the shear bending moment diagram will go down at the C point, okay. Now when we take the section at next point, that is C point, and when we calculate the moment at C point, then on C point here we can see the moment of RA is RA into perpendicular distance, that is 10, okay, and the moment of this 50, okay, moment of this 50 is minus, okay. So 5 into 10, okay, 5 into 10 minus 50. So here we can see the moment at B point is 5 into 10 minus 50. So 50 minus 50, it is 0. So your bending moment diagram will close at that point, okay. So now this is shear force and bending moment diagram for the clockwise and anti-clockwise movement acting at the center of simply supported beam. Now in the next we will see the comparison of both. See, this is clockwise movement and this is anti-clockwise movement. Span is same, and now here we will compare both the cases, means simply supported beam carrying clockwise movement and simply supported beam carrying anti-clockwise movement. So first, going with the support reaction at A point for the clockwise movement is minus 5 kilonewton and at B point is 5 kilonewton. So when the movement is anti-clockwise, okay, so when movement is anti-clockwise, then support reaction at A point is plus 5 kilonewton and at B point is minus 5 kilonewton. Now here we can see the support reactions has been changed. It means whatever shear force diagram is there, that shear force diagram is also changed. So this is baseline. So in this case, see, in this case our shear force is negative direction because of our support reaction is negative, so it goes down. But now in this case the shear force diagram goes positive because of this RA positive. See, this is downward and this is upward, okay. Now at B left, okay, for the first case B left is constant, and here also it is constant, so it will go constant up to the B left, and after that B left it will be closed, okay. So the conclusion is what? When any simply supported beam subjected to a clockwise movement, then shear force diagram is negative, and when the simply supported beam carrying anti-clockwise movement or couple, then shear force diagram is positive, okay. Now the next is the bending moment diagram. Let's say this is our baseline, okay. Now we have gone through that. When the beam is subjected to a clockwise movement, then shear force diagram is what? Okay, shear force diagram is negative, and when beam is subjected to anti-clockwise movement, then shear force diagram is positive. And at the C point it will suddenly change, okay. So when clockwise movement is there, so diagram will goes to the positive, and when anti-clockwise movement is there, diagram goes positive to, okay, it's positive and it's negative, and then after it will goes to the closing point, okay. So this is the shear force and bending moment diagram of the first case, that is being subjected to a couple. This is a numerical. Now we are going to cover few numericals with the different loading for the simply supported beam, and then we will talk about the cantilever beam. Okay, so we are planning to upload some videos to show the shear force and bending moment diagram for the different loading. So now we have covered the standard cases. Now we are going to the actual numericals, means we will take different types of numerical that we are going to solve in the upcoming videos. And once we complete the shear forces diagram for the simply supported beam, then we will talk about the shear force and bending moment diagram for the cantilever beam. But before that, we will cover some basic parts as we have covered, like simply supported beam, and then we will move for the actual numerical for the cantilever beam. Okay, so hope you are enjoying my videos. So if really you are getting some knowledge from this video, so please like and subscribe my channel, and click on the bell icon so you will get the notification. So as I am planning to cover all the subjects in the videos, like engineering mechanics, then strength of material, structural analysis, design of reinforced concrete structure, design of steel structure, design of steel structures, and I am planning to upload some videos on the points which are related or which are important for the field point of view, and also I am planning to upload some videos on the software training also. So really, if you are getting some knowledge from this video, so please like and subscribe my channel. And these are the topics already we have covered in last few videos, so you can go through that. I will give the link of all the topics in the description box. Okay, so thank you so much.